Okay, so we're going to do another example that will hopefully demonstrate a couple of things. Um, so we have here the problem to evaluate the integral of x squared cosine 2x. And by the way, it should be clear at this point that we're using integration by parts in a situation where u substitution itself wouldn't work. You can kind of see what would happen if I tried to write u equals 2x du equals 2 dx. The problem is that if I did that, I'd have this part of the original integrand that I'd have to clear. It's like maybe I could rewrite this as we could say u over 2 squared cosine of u du, but that's not any easier to integrate. So that's why we're not using integration by parts, because why we're not using u substitution, because u substitution just isn't going to lead us anywhere. So it takes a little practice to see what types of problems work better with integration by parts, but you will get the hang of it if you just do enough of these. So let's actually write out the solution to this. So the first thing we do is we're going to choose u and v. So I'm going to choose u equals x squared and dv equals cosine of 2x dx. Now, you might wonder, how did I know to choose that? I mean, there actually are a couple of different problems where you have a choice of what you're going to choose for u and what you're going to choose for dv. But in many problems, the choice kind of suggests itself. The first rule is I want to choose dv to be something that I can easily find the antiderivative of. If I can't easily find the antiderivative, then it's not going to help me to choose that to be dv, because remember, the first thing I have to be able to do is write what v is by looking at dv. And if I don't, if I don't have an easy way to find, say, the antiderivative of cosine of 2x, then it's not going to help. So you want to choose dv to be something that you can fairly easily find an antiderivative of. The next thing to note here is that you want u to be something where eventually you're going to get it's going to eventually differentiating u is going to take you down to a simpler form. And what we're going to see here is that if I differentiate u once, I'm going to get 2x. If I differentiate it twice, I'm going to get 2. And so I'm getting closer and closer to just a constant, which is a fairly simple form to deal with. So that's another good clue that you've chosen u and dv correctly, is if differentiating u leads you to a simpler function and dv is something that you can easily find an antiderivative of, you're probably on the right track. All right, so let's continue with that. So let's see. So du is going to equal 2x dx, and v will be 1/2 sine of 2x. You could do that by u substitution if you wanted to, but I think most of you by now may be familiar with the fact that the integral of cosine of ax is just equal to 1 over a sine ax. That's a formula that's worth remembering. All right, so let's write out where we are at this point. We have x squared. Actually, let me write in what these are. So that's u, and that's dv. So I have x squared, integral of x squared cosine of 2x dx. Sorry, that actually includes the dv includes the dx there, and that's important because you have to clear out the dx when you do this. So let's take uv. It's going to be x squared over 2 sine of 2x. That's the product of u and v, slightly simplified. And we're going to subtract from that 1/2 times 2 is just 1, so 1/2 of 2x just gives me x sine 2x dx. So this is going to be v du, and this is going to be uv. So okay, so I have done that. I've done that step. Now let's take a look at what you see over here. We see as we have integral of x sine 2x. That's another problem that's just going to be fairly difficult to do by u substitution. In fact, you can't really do it by u substitution for a similar reason to what I demonstrated. So that's not going to work. What we do have is another problem for which integration by parts is likely to work. So what do? We just do it again. So let me put in here. We're going to do this subproblem. I'll do it in green to distinguish. And then we're going to plug the integration by parts solution to that subproblem back into the original problem. So I'm going to use u and v to mean something different now. So now it's going to be u equals x, and dv, I'll set that equal to sine 2x dx. So just to be clear, using now the green notation, that's going to be u, and that's going to be dv. So du will be dx, and v, the antiderivative of sine 2x, is negative 1 over 2 cosine of 2x. Okay, so now let's try to keep the color coding straight. This becomes the original problem, the integral of x squared cosine 2x dx is equal to x squared over 2 sine 2x. In other words, that just comes right from up here, from where I wrote it. And now let's switch to green. This is going to be minus, and I want to replace this expression in the green box with its integration by parts equivalent that you see in the green writing. So that's going to be minus negative x over 2 cosine of 2x. In other words, this is just uv. And now plus, so I'm going to subtract now minus v du, but I've got a negative sign in that v, so I can just write a plus here. So that's going to be plus integral of 1/2 cosine of 2x dx. So in other words, I've now replaced what's in the green box with this expression, where this is now going to be v du, like that. All right, so now we just need a little bit more. Algebra. So this becomes now the integral of x squared over 2 sine 2x. I'm just going to simplify this. This becomes plus x over 2 cosine of 2x. And this now, the antiderivative of 1/2 cosine of 2x is just going to be, this is going to be 1/4 sine of 2x. So I'm distributing that minus sign, so I'm going to subtract 1/4 sine of 2x. I realize the minus signs and distributing the minus signs gets a little confusing, but you can slow down the video and try to follow that. So I have this, and now we're actually at the end of the problem. So we can just write the hardest part of the solution. Since this is an indefinite integral, that's a plus c, and there we go. That is the indefinite integral of x squared cosine of 2x dx.